2017, a sophisticated cyber attack known as Triton, or Trisis, targeted safety systems of a power station in Saudi Arabia, making a significant escalation in industrial cybersecurity threats. The attack focused on the Triconic's safety controllers, critical systems designed to prevent hazardous incidents. In other words, this is a safety system designed to warn workers when conditions were unsafe, such as the level of dangerous chemicals being in the air. Although publicly reported in December 2017, early warning signs appeared months earlier. In June, an unexpected shutdown initially attributed to a mechanical failure raised little suspicion. However, a second shutdown in August prompted a deeper investigation, ultimately revealing the presence of malware. The malware, later named Triton, exploited a vulnerability in Microsoft Windows-based machines to infiltrate systems connected to the safety infrastructure. Triton leveraged a zero-day vulnerability to establish persistent access and to manipulate safety controls. The attack exposed serious cyber-physical risks. Notably, Triton is considered the first malware specifically designed to disable industrial safety systems, potentially endangering human lives. This is a story about the need to secure legacy cyber-physical systems and what type of person might be best for that role. I'm Robert Vamosi. This is Error Code.
My name's Dan Gunter, and my job title is CEO and founder of Insane Cyber. So Insane Cyber, what we're helping critical infrastructure and asset owners extend their security. And so a lot of great work has been done in this space on passive network monitoring. But one of the really big challenges of the industrial space, OT systems, factories, power, oil and gas, and other critical infrastructure sectors is the sites are often spread out. So you have a geography problem, and then from a talent perspective, the OT workforce is a small niche workforce of the overall information security workforce, right? And so our tool helps with the scale of what an asset owner can cover to cover the realities of their environment, but also help their team members, already stretched teams, be more capable in the space.
On Error Code, I talk a lot about cyber-physical systems. What exactly does that mean? It means systems that have physical consequences in the real world. So, a robotic arm in a factory, or a conveyor belt in a store. You might not think of these as being cyber, yet there are PLCs inside that handle much of the on, off, and measuring the load that are important to its function overall. So, I'm just going to go right into it and say, it's 2026. Why does Dan think it's taken so long to recognize the importance and vulnerabilities in the OT space?
I think on one front on it comes to budget, right? The operations budget at many asset owners is many multiple higher than the security budget still, right? You'll have asset owners that are like, hey, I need to invest in security, but just like other businesses, it's a cost center, right? And so some of the resistance is sometimes how the story is told, like, right? Is this threat legitimate? Could this really happen here, right? And there's skepticism on that side that cause people to go down that path of like, let me just do nothing, right? The cost of doing nothing is, lower than the cost of doing something. And I'm not actually, having impact, right? There's folks in the world that still do kind of believe that. On the other side, and this, you can go into an individual asset owner, and what's interesting is they may be secure on their security program on one part of the process, but not another. These industrial sites, like, right, it's not like, IT system refresh when it's like, let me just go order from Dell. Like, we have asset owners that have, they built a refinery 50, 60 years ago, and every 10 years they built a new part of that refinery, right? On the power grid, what goes into a substation, the life cycle for those systems is 15, 20 years. And so from an IT perspective, right, a lot of folks will be like, hey, after 3 to 5 years, you're replacing this, right? And it's like, no, like because of how the grid's built. Like those asset owners think in like 15, 20-year windows, right? In addition to just the cost, right? It's not as easy to just plug a system in and call it a day. There is the cyber physical aspect, part of the problem, right? This is driving pumps out in the wild. This is moving, if you're at a refinery, benzene, if you're at a mine, vats of hydrochloric acid, right? And so it's not an easy, the security problem is much harder because of that cyber physical and everything else that's at play, right?
I want to continue to explore the cyber-physical disconnect. A lot of people think that OT devices are, well, just machines. Machines out in the field doing one task. But we've networked them now, and they've now addressable from all parts of the world.
Absolutely. And it's crazy, right? You look at the history, and in the 50s and 60s, actually, where like, when we talk about programmable logic controllers today, to your point, the computers, the industrial computers that are driving things, or the HMIs, the human machine interfaces that control those. Back in the 50s, 60s, like, the first generation of these PLCs was built because General Motors, I think, one of the car manufacturers was like, hey, right now in this automotive plant, I literally have to run a wire from here to here, and every system required a wire. And in the 50s and 60s, they're like, hey, like it turns out we can run multiple of these wires into these industrial computers and just let the computer handle the switching and do things. So instead of my factory having hundreds of miles of wire or more, like we can do it with less, right? The challenge is like, right, over decades, those systems have changed, but to the point of legacy systems, you'll still sometimes run into like old equipment that is decades old. We'll commonly see out there like, routing equipment that the company's not even around. And you see a stack of routers because the network's literally still like tied to, that legacy equipment that luckily they still have a stack of in there, right? And so it's the problem in this space and that cyber physical side, because it is tied to the actually driving things, to your point, like it can drive a lot, right? It can move things around, it can open valves, it can turn engines on and off, right?
Dan offers a real-world example. Airports. If you step back, airports have a number of OT systems that could be considered life-critical, although you might not realize that.
I started my career in the Air Force. At some of the Air Force bases, right? If you go to like a refueler Air Force base or a cargo base that has like cargo planes, like it literally takes dozens of trucks if you were to send a truck out to fill that. It's much more efficient to be like, hey, let me have a fuel pump that's pumping gas under the runway so I don't have to go there, right? Closest civilian side's that is London, right? The London airport today, right? I'm pretty sure they're pumping fuel and doing things to get it there instead of rolling trucks, right? And so to your point, like what makes industrial fun is the purpose those computers are around, right? Last one I'll say on this one is like baggage systems, right? We talk to folks and it's like, what would be the worst way to disrupt an airport? And they're like, well, all of the industrial computers that are moving bags around, right? Because then both the airport has a problem that people can't get their stuff. And to that point of like PLCs and what it's driving, like it's critical and people don't think about it till it's down, right?
What's surprising to me is that it's taken so long for the cybersecurity community to realize OT security, but also adversaries. Do they realize that they don't have to steal data anymore? They can cripple functioning systems to drive their point home?
And that's where the field has changed, right? I mean, we've been, back in World War I, World War II, the military would more just bomb or blow up critical war supporting infrastructure, oil, tank factories, other things. Now, like, it's digitally connected, right? The world has changed to where like sometimes you don't have to risk a person physically going forward to cause the effect that, happened in World War I physically, right?
A lot of these systems, to Dan's point, were getting rid of wires. They were making things simpler. They were using protocols that were designed to do just two things. Flash forward to today, and we have the IoT systems that are out there, and they're saying, let's take this really old protocol that communicates, and that's all it does, and bring it into this device that I'm going to put into my home hub or something like that. What they don't realize is that it hasn't been vetted as much over the years, and it hasn't improved over time. It's an old protocol. It's still back in the 1990s when it was first created, and that is the sort of problem that you see in the OT world today.
That is, I mean, there's industrial protocols to where, you'll have PLCs that are still on serial connections, still on the more non-Ethernet connection, and they'll go through a serial to Ethernet converter. Well, when it comes to the IP side of the network, all that's being done is it's being put on that TCP or UDP packet, or even in some industrial processes, it'll actually get put on like a broadcast or multicast or even like some industrial protocols don't use TCP or UDP, it just throws on Ethernet. And those are fun, right? But what's fun, like, right, from a evolution perspective is those devices still talk to each other. And so there has to often be some interoperability where you have like a IP, like Ethernet based network and serial. And, you're exactly right. A lot of those protocols don't have authentication. Like at best, they've just thrown it on and it's like, okay, PLC 2 on the digital network side is talking to PLC 5 on this side, and all that's being done is thrown on that layer. To your point, what's interesting from the security perspective, right, is attackers then can spoof that, right? They can take some of that advantage and be like, hey, let me just stack a packet like this and make it look like it came from that other side or work through it, right?
Dan mentioned IoT earlier. Like embedded systems are a challenge. For a security team, they may see the communication in and out, but they don't necessarily know what's operating under the hood.
From a security team, embedded systems to a stock are a bit of a black box. They maybe see communication, but on most of those embedded devices, you don't get good host logs unless you kind of have fancy ways or know to pull it off, right? Um, to that point, too, the system's becoming a lot more accessible. Some of the programmable logic controllers that are out there, some of the asset owners actually, to efficiency side, are like, hey, if you want to deploy Python code out to this PLC, here's this way to do it, right? And so it's almost making it easier for folks that even can pick up Python, which is pretty, straightforward to learn. And, if you can get past the access point, use them for that. Use them to mine Bitcoin. Use them to kind of live on to cause and effect, right? And so you're exactly right. Like, right, they're becoming a lot more powerful just in that purpose, right? And on the flip side, on the safety side of it, like, right, they have to be mindful how engineers architect these PLCs, right? They need to make sure like the action that's supposed to happen with the logic they put on there happens, right? And so there's a trade-off between going too secure versus like, hey, I'm going to trust that what's in memory or the code on here is what should actually be executed.
Returning to something Dan said earlier, these systems, I've always said, were really like a Tower of Babel. Everything's proprietary, everything's small, so overall, you probably don't need to worry about them being attacked. Well, that's not true anymore. There's more generalization going on, and things are getting much more interconnected.
That's part of the problem. It's also a problem in the industrial space. Like a lot of the OEMs have been bought a few times. And so you'll have a major company like Emerson. Well, Emerson bought Westinghouse. And so when you look at some of the technology, when you look at the protocols, like that was actually some of the technology came through acquisition or came through others. Similar to that side, Schneider Electric has a safety system called Triconics that was used in or it was targeted in the Tricis Hatman kind of intrusion, right? But it's a safety system. They actually were not the inventors of that. That was IP they bought via acquisition and came in. The protocols, it's funny when you're actually at the analyst level, you see that, right? So sometimes you still see like, oh, hey, if I pull Westinghouse's manual from 30 years ago, to your point earlier, you were saying the protocol is actually very similar. There's just changes maybe Emerson has done, as they've modernized that product line as they push, right? And so, what makes it really fun for us is it is that box of puzzles. And sometimes it's like, oh, like, hey, like, has this actually changed or is this the same protocol that is in there? And you get into certain places like where Westinghouse is interesting, right? The nuclear sector, right? Some of our most critical infrastructure, a lot of it runs on Westinghouse, right? So you see kind of not just across like that, changes as it changes hands, but it's important to kind of know like hey, how has the tech actually changed? How has this changed across time, right? And you talk change control and change configuration and all that, like nothing is more critical than nuclear, right?
Given the variety of older equipment out there in the field, from companies that have changed hands or even gone extinct, how does someone like Dan become a jack of all trades? How does he know that this was originally Westinghouse, or this was originally Philips, or Western Electric, or whatever it was back in the day?
Some of it is where, OT is a niche for people that enter the field. Luckily the OT talent market has grown, right? It's the job market and the number of people in the space. We still need more people, good people in the OT security space that can learn it, right? We need folks that can kind of, pick up the carpet a little bit and see what's underneath it. A lot of our learning also will happen. Like we use some of the manuals that OEMs provide and be like, okay, this is how it's said it's produced, but we'll also work with the asset owners we work with and be like, hey, let's go to this power plant. Let's go to this substation. Let's start to pull packet capture. Let's start to pull Windows event logs and other data. And let's see like how it actually works. And if we have to work back to the functionality to know how to secure it, great. But it all starts with kind of that pulling that thread. And like from my perspective and having been in this space, like there's no better opportunity than when you can partner with the asset owner and be like, hey, like let's understand a little bit more on this environment, right? Because what we see is like, right, we'll work with really smart electrical engineers, really smart mechanical, petrochem, other engineers, and they really understand how the process works. Well, my background's mainly in computer science, right? And so when I come in with that computer science perspective, like bringing that in can help, because they're doing great engineering work on that side, but it's like, okay, how would a computer scientist think on this problem, right? And someone from the infosec and specifically OT space.
I also wondered if Dan runs across the white label problem, where you're told the device is X, but then you discover that it's actually mass produced as something else.
All the time. And a fun one on that is for vendor remote access. It'll be like, this is vendor so and so remote access, and it's on port 3389. And it's like, are you just calling Microsoft Remote Desktop Protocol your thing? 9 times out of 10, it is. And so, sometimes you'll see those, you have that issue, right?
Apart from having the proprietary stuff, there are commonalities, like Modbus keeps showing up everywhere. It seems like it's functionality or protocol that's being used widely.
Modbus is that one. Actually, the Modicon group, going back to the auto plant conversation earlier, Modbus actually came out of that auto plant. And so it is kind of the OG protocol in the space that was used to pull in and has been the history of a lot of modern day PLC and OT kind of technology. Where it's fun today is you have kind of the base protocol that's like reads, writes, basic things you do to a PLC. Get things in memory, read them from memory. The ladder logic that changes different values and drives motors, drives other things out there. What's challenging is you take a protocol like that, and there's actually like a vendor specific space. And so a vendor like Schneider Electric, a vendor like GE or anyone else that's using Modbus can say, okay, I love this base protocol. I need to add more features, right? Because to the point earlier, my PLCs are getting more complex. There's things I can't do just in kind of the 16 common or 18 common function codes. And so it's also fun because these are like, right, IEEE specs. And so sometimes you see a difference between like what is in the IEEE spec versus what did the engineer at the OEM actually intentionally implement, or what did they misimplement? And it's not actually the protocol that you have from the engineering docs, right?
So, how does Dan approach tackling this problem, given all these desperate systems that are out there?
Yeah, it all starts with figuring out what's important to them immediately. Like, right, priorities do move. Like, what is the boardroom asking about? What is management outside of the operations group or IT group or whoever's caring about OT security at the point kind of cares about, right? And so it starts with really an understanding of, what do you care about? Have you had ransomware lately? Has that ransomware activated? What's interesting in this impacted you, right? What's interesting in this space is when you talk about this space, like incident response, bringing things back up from ransomware, asset owners have those costs, right? but the bigger cost to most asset owners is the cost of downtime, right? You look at Ponemon Institute, right? Independent numbers on the cost of downtime. Automotive's a $2.4 million an hour average downtime. Oil and gas is a $1.6 million an hour, according to Ponemon Institute downtime. So not only are you losing from the cost of incident response and the stuff that your security program has to pay, but that other program. So where it goes back to that priorities is sometimes you come into a situation where they're like, you know, hey, like the automotive things we saw last year overseas, right? Our plants were down for a few weeks. This cost us a significant amount, in lost production, in loss of safety, right? So understanding kind of those. We also start with just maturity, like how much of your environment can you see? Do you understand what's being told? Um, how much of, to the point on Modbus, how much of Modbus, if you have Modbus in there, do you actually understand? And how much is making it if you're using a tool like Splunk or some of the other seams, like what's actually making it up to the SOC to make decisions on, right? Um, Starting with that kind of understanding of where they're at, then it is that side of like, you can't boil the ocean, right? Where do we start to get some of that impact, right? Is it a visibility problem? Is it a access problem? Like, right? And, look, we are a vendor that has a product, but ultimately at the end of the day, like the OT space is all built off relationships, right? And so it also comes down to you want to help folks with like that immediate problems because eventually like it builds the relationship then to kind of get to maybe where we as a company want to get, right? But it starts with that side of like realizing that in these environments, like, right, uptime's important, right? Availability, but the like confidentiality and integrity, can even be key, right? Especially availability and integrity are huge, right? So starting with those parts of kind of the CIA triad and having that scaled plan, right? How are we actually measuring that we're not just doing a lot of activity and wasting time, right? There's some good kind of industry-wide ones on that, but sometimes it can get really personal, right? If people come in with needs and wants. So
This sounds like it's not too dissimilar from someone saying, secure my network. You immediately say, well, let's secure your crown jewels. What is the most important thing that you want to protect?
and it goes back to where it gets more interesting to folks in this space is it goes back to that cyber physical, right? So if someone's able to cause an impact, it impacts actual operations. If that's in a refinery and it overpressures a tank or does something like that, and there's not a compensating safety control that reacts to that, like the other calculus in there is the reconstitution in that time, but also like do I have parts on hand to fix this part of the physical process that's broken, right? If someone comes through and bricks a lot of PLCs or comes through and actually causes physical damage in there, like, do I have availability on a lot of that? With industrial processes, like the PLCs in themselves, the supply chain for those is easy. But when you get into some of the bigger parts of a refinery or a substation, like you're talking about things that asset owners may not have in big quantities, right? Or they may be very expensive to get, or they have to hop on a boat to come across the ocean to be even be here, right? And so it's that's where the problem I think also, really does differ a little bit from the IT side, but it is like you're exactly right on what you were putting there on crown jewels and some of that other approach.
So Dan mentioned socks, and I hadn't really thought too much about it. But are socks paying attention to OT, or is that still something that needs to be stepped up and improved?
That's one of the fun as you get to know companies. There are places that try to run separate IT and OT SOCs. I'm of the opinion that that just creates two groups during incident response that have to work together. If you take like some of the NIST publications on how to build incident response, some of the other stuff, actually a lot of the NIST, there are really good NIST docs, which are like, hey, this is how the US government and the folks that participated on those NIST committees recommend to do the security program, right? And right, you take like plan policies and procedures, right? When you're at your policy side, it is important, right, to if you have one SOC, you want to make sure, like, right, you give the authorization and the permissions and everything so folks aren't having to do it, right? If you have two, what gets challenging to that perspective is you have to make sure like your plans, policies, and procedures for incident response for SOC operations, like that like when something happens, you're not picking up the phone and calling someone and they're surprised that you're even calling them, right? Um, it becomes even more challenging when you take like a Colonial Pipeline incident, right? When the East Coast pipeline was pushed out, right? Um, there's a lot of like speculation and folks that have guessed on what happens on the outside, right? But it sounds like there was some impact to IT systems and others that do impact the other side, right? And you even hit the side of on any utility, right? If a utility can't determine how much power you're using and bill you for it, like we don't know how that utility is going to react, right? Because they're a utility making money off of moving and selling electrons, right? And so, where it becomes interesting and on that stock perspective is they have to work together in harmony. And we go a lot of places to where like there is animosity sometimes between the IT side and the operations side. And people have been talking to convergence on decades. Like the network has been converged for decades. The politics is the part that's still being worked through now.
I wondered if Dan had any war stories to bring in the discussion, something he offers to a new client.
Definitely, I think like the big talked about Ukraine 2015 and 2016, the Trisis, Hatman, whatever you want to call the safety system, those are key ones, right? And even in Destroyer 2 is a key point, right? And the interesting things on that, right, is in the Ukraine 2016 incident, like, right, there's videos out on the internet of folks moving the mouse around and
Yep.
opening breakers, right? It was a very kind of manual deal, right? And then you get into Ukraine 2016 and they start writing malware. And then a few years later, right, we see malware that's actually OT capable. The kind of scary thing for the OT space is going back to the Python example. There's some really good Python libraries for industrial protocols, right? Um, what's short, luckily, on the attacker side is they don't know sometimes what to send or where to go to. And so, like, where we start is some of that understanding, right? We have open known cases of people moving a mouse and videos out there of the mouse opening breakers and doing things. Someone's like TeamViewered or RDP'd or however they're actually in. We also have like several examples now of folks actually writing code, actually doing that. What I'll share to an interesting level is when you get into something like Trisis, I think some of the reverse engineering reports, so that used a very proprietary protocol. That was like definitely a top shelf, higher end, harder thing for that attacker to do. There was a lot they didn't understand about the protocol, and we've seen that across a few things where the attacker either misimplements it and it didn't work as they intended, luckily, and they didn't know what was wrong. And as a community, we never want to point to like, hey, attacker, here was the bug in your code that would have made this work that didn't, right? But I think that becomes more critical, right? Because like again, we have seen human driven, we have seen kind of code driven attacks. We've seen ransomware on OT. We've also seen, more nation state impact, right? Go back to the OG impacting uranium enrichment in Iran, right? Like that was really, I think, the first known major, nation state to nation state assumed impact, right?
Dan points to the 2010 Stuxnet attack on the Iranian centrifuges, a brilliant attack requiring both IT, in terms of Windows vulnerabilities, and OT, PLC-specific malware.
What's interesting with that is you have a mix of like the industrial protocols being used. You also have a mix to where they were just doing things that you see when any Windows attacker do, right? They were
Right.
hooking DLLs. They were doing other things that are more like non-OT attacks that are still critical, but that's how they, right, were able to get the centrifuges to spin at a speed that was not what the computer was, not what that engineering workstation or HMI was saying it was spinning at, right? It
Right.
was that hooking is very similar between both. And I think that's an interesting point when you look at OT malware, right?
So what Dan's suggesting is that Stuxnet might be an extreme example of IT-OT convergence.
Yeah, yeah. It's been converged since 2000, what, 2008.
So how does one get into this line of work? Do you need to come from the CSCE side, or can you come from anywhere?
It's critical for folks to get started in, right? And everyone has to start somewhere. I started my career in the Air Force. I just started doing OT stuff in the Air Force too, going out, right? Some of the best talent in the world, whether it be in the US, whether it be in Israel, does start with US military or IDF or other service, right? To get that. I think as a community, something's big, and I'm curious on your opinion, talking to people on how getting in, like, people can start military. There is an approach, I think, for folks to kind of start getting a job, right? Intern at an asset owner, become a part of the security program that has, cyber physical consequences on both sides, right? But what are your thoughts? Where do you see where we can solve some of the workforce gap that you've seen work on other areas?
I think the problem is that the workforce out there doesn't necessarily understand the OT space.
Agree. And I think a lot of opportunities are popping up on that internship side, on the side as we understand, and more money is going into the criticality of the problem, right?
Right.
What's interesting for us is always seeing like also what are the priorities, right? What are the national funded priorities when it comes to OT security out of DOE or CISA, right? How does that change, right? But globally too, right? Because to the point of enabling even folks to start an industry, like that does matter, right? How do we build the workforce? How do we prepare them, right? How do we take someone out of school and get them in the problem or get them into the problem space without gatekeeping, right? I agree with you in this space. We do often, I feel like, over gatekeep to where folks are like, oh, start on the help desk, start on others. And yes, like some of that IT experience is key, but you also have some smart folks that may be coming out of doing their PhD, may come out from some of the top tier universities, even in undergrad, doing that interesting work.
If you're not from the cybersecurity background, then where has Dan found success in hiring?
Some of the like most talented people I've worked with, some have not actually had any previous InfoSec experience, but they have come in again. Like one person I worked with, they were working with a company where they were doing like it was one of the automotive companies that you can like open the door, rent a car, open the door, and use the car. And their infrastructure to do that, he was more actually on the site reliability on the IT support side of that. But on that, he had scripted a lot of efficiencies to kind of work through that side. And so, me as I was hiring and working through on it, it was like, okay, this person like has worked at a company to where like they're unlocking doors and turning cars on and making sure like, right, if you use your app and can do that to the car, that it's the car it should go to, that there's a lot of risk going there, right? Um, Person ended up being an amazing security hire because he started with that tinkering side of just, hey, I'm working at a utility that has to do this or a SaaS app that has to do this, right? And it can start there to where, and he had no traditional education, I don't think, beyond the high school level. It was all learned like, from that practicality side.
To Dan's point about gatekeeping and stuff, there was this barrier about 20 years ago where it was like, well, you don't know enough. As a journalist, I got my CISSP because I wasn't being taken seriously. People were like, well, what do you possibly know? You're just a journalist. It's like, no, let's talk about this. Let's get into the weeds. So it's nice to see that some of those barriers are coming down. And then, to my point, it seems like the people that I talk to in this OT space have been the garage tinkerers, the ones who decided to take apart a smart meter and tear it apart themselves to understand its internal logic and then rebuild it again.
Yeah, and I'll point out too, like what's interesting in our space is some of the most successful like red team engagements where we're actually breaking in and causing an impact either on a lab environment or small factor safe way of doing it. It's actually come from going to like non-computer science, non-cyber like electrical engineers and being like, look, you sat at this console for the last 15 years. You've distributed power and done this. Like, what would you do if you were an attacker, right? And some of that conversation, honestly, as we work through the problem, led to like paths that we would then take to a red team engagement or take to detection engineering if we're working on the blue side and be like, hey, let's make sure we can't do what that really smart power systems operator that doesn't know much about cybersecurity, but he does know the power system. Like, how do we incorporate and bring that in, right? And we've had a ton of wins, right? And so when we go on site, like, right, we'll try to talk to both crews sometimes in separate rooms to be like, hey, let's make sure this isn't being pulled into someone's cognitive biases or into like groupthink, right? Or that people are scared to bring up like, hey, this is what I would do to bring the grid down pretty quickly, right?
Well, that is the thing, because bad guys often come up with the thing that is so off the wall, out of the box, or insane that why didn't we think of that first?
Oh, absolutely. Absolutely. And that's what I'll say to anyone thinking or listening to the podcast, thinking of going in this space. Like a lot of people, like that's what drives them, right? Not just the like, computer science side, but that side of like, hey, how does this work? How would like, because like, right, as defenders, we want to find it before attackers do. If we can't patch it, at least get the monitoring there, right? And when you talk about like validation at the end of the day and feeling like you're making an impact, like there's nothing better of an impact than knowing that you either kept someone safe or kept that level, right? Because the consequences, right? Like you go to a refinery dealing with benzene, right? If that benzene gets out, like the cancer rates are going to go up within miles of everyone in that area, right? And
Right.
it's the consequences are like you never want to overstate or fearmonger, but the consequences are significant, if something should happen, right?
Right. I'd like to thank Dan for coming on the show and talking about the need to secure legacy OT systems. It's a topic I've covered before, and I suspect I'll be covering it again. Hey, if you're enjoying Error Code, tell a friend. I'm sure there are other people out there who like narrative information security podcasts. And I'd really like to hear from you. Go to errorcodepodcast.com to get more details. And tell me what you like, and even what you don't. I've got some great episodes coming up. We'll have more on Volt Typhoon, Salt Typhoon, and hacking utilities supply chains. Subscribe today. I don't want you to miss out.